Okay, welcome back. Now I'm going to do another example. So now let's see what we get here. As we do the limit as x approaches 0 from the right, what do I get? This is going to 0, and this is also going to 0. So I'm getting the indeterminate form 0 to the 0 power. So now what I'm going to do is I'm going to take the natural log, right? So I'm going to take the natural log, so I'm going to start with y. Let's define y. Oops, keep wanting to jump the gun here. So y equals x to the power of sine x. And now if I take the natural log of both sides, I get the natural log of y is equal to sine x times x. Okay? Now, if I take the limit of this, the limit of the natural log, the limit as x approaches 0 from the right of, oops, hold on. That should be the natural log of x. Equals the limit as x approaches 0 from the right of sine x times the natural log of x. Now what happens here? Well, this is going to 0 and this is going to infinity. So now I've got another indeterminate form, which I thought I wrote down. Hold on, maybe I didn't write it down. Well, I wrote them all down. I might have accidentally erased it. Oh, yeah. Yeah. This should be times. I wrote down wrong. So this should be 0 times infinity. Okay, so now, so I've got another indeterminate form. Okay, so now what do? Okay, so this is where I have to kind of manipulate the expression again. Okay, and so in this case here, since we got another indeterminate form, we're going to use L'Hopital's rule, but we have to rewrite the expression. So now, what I'm going to do is rewrite this as a fraction. So I'm going to get the limit as x goes to 0 from the right. And now what I'm going to do is I'm going to bring this down to the bottom and take the reciprocal. So this will be sine x over 1 over natural log of x. And now if I take this to 0, is that what I want to do? Yeah, so if this is going to 0, I get 0 on the top. Natural log of 0, as I get closer and closer to 0 from the right, this is going to negative infinity. So which means this is going to 0, so I get 0 over 0. So now I've got the determinant form. Now I can use L'Hopital's rule. Okay, and so now I'm going to take the limit as x approaches 0 from the right. Now the derivative of sine is cosine. The derivative of 1 over the natural log of x, that's going to be, well, again, I can write this as the natural log of x to the negative 1 power, which means I get negative what? Negative 1, and I get the natural log, oops. I get the negative natural log of x times the derivative of the inside, which is 1 over x. Okay, now, what does that give me? That equals the limit as x approaches 0 from the right, and now I'm going to write this as x cosine x over negative natural log of x. Okay, so now, as x is going to 0 from the right, this is going to 0, this is going to 1, so this top is going to 0. And the bottom is going to negative infinity, but it's the opposite, so it's going to positive infinity. Oops. So this is getting bigger, this is getting smaller, so guess what's going on? This is going to 0. Now, we're not done yet. What was the original thing we did? The natural log. So we just found the limit of the natural log of y. Okay? Which means then the limit as x approaches 0 from the right of y is equal to e to the limit as x approaches 0 from the right of well, I'm not going to write all that out. But since the natural log of y, so since the limit, right? So the limit of this, the limit of the natural log of y gives me 0, then the limit of e to the natural log of y, right, is equal to e to the limit, which is 0. Oh, let me write it this way, which is equal to e to the limit of x equals 0 of the natural log of y, which equals e to the 0, which equals 1. And so the limit of the original function, the limit as x approaches 0 from the right of x to the sine x power is equal to 1. Have a great day.